Hey, Math 1, welcome to Chapter 3, Section 8. We are getting back into some algebra here with multiplying polynomials together. Let's get started. All right, so our goal today is to, there we go, understand what a hey, boo. Let's try that again. Understand what a polynomial is and find the product of polynomials, right? No problem. This will go fast, I think. So, first we want to remember some vocabulary. Do you remember from Math 8 what a term is? A term could be just a number, like the number 7. Could be just a variable, like the most popular variable, x. Or it could be the product of numbers and variables, like maybe we have 7x squared y, right? These are all considered terms. Even this thing over here, which is a bunch of stuff multiplied together, is just a single term, right? Something I would point out here is that there are two types of terms. Let's do this in a different color for the heck of it. So this is called a constant term, whereas these guys are called variable terms for the obvious reason they have variables in them. Where a constant term is really just a fancy word for a number. In math, a number is called a constant. It doesn't vary. It's constantly the same number, unlike a variable, right? And expression, right? So an expression is simply made up of terms being added or subtracted. Let's go down a little bit. Individual terms, you can see, are separated by addition and subtraction signs. And expressions are made up of both variable terms and or constant terms. So maybe we have 2x squared plus 3x minus 4, right? That would be an expression with 3 terms. Right? Terms are like the building block that make up an expression. And maybe we have something like x to the 5th minus 1. That would be an expression with 2 terms, right? All right, enough about that. What is a polynomial? Well, a polynomial is a special type of expression. Not all expressions are polynomials. They have just a couple basic rules. All right, a polynomial is an expression where all of the terms look like this. Now that's a little confusing, I know, but I'll explain it. They have a real number here, which is basically every number we use right now. It's every number we use in Math 1. They may have a variable, or they could have more than one variable, and they can have an exponent. So something really basic might be like 3x squared, right? 3 is a real number. It's got a variable, though it doesn't have to, and the exponent is a whole number. I forgot to point that out. The exponent cannot be a fraction or decimal. It must be a whole number. And I don't remember from Math 8, but whole numbers are not negative either. So it's got to be 0 or a positive whole number. A polynomial may not have negative exponents on the variable. For instance, we cannot have 5x to the negative 3rd. I'll tell you why in a second. And a polynomial may not have the variable as an exponent. You cannot have something like 2 to the x as one of your terms. Let me go over a few examples and tell you why they are or are not polynomials. So perhaps you have 7x squared plus 2 over x. All right, this is not a polynomial because actually this equals 7x squared plus 2x to the negative first. Remember, you are not allowed to have a negative exponent, and here's the reason why. Negative exponents are not allowed because they actually would make you divide by a variable. So, no division by a variable, and that is what a negative exponent makes happen. No negative exponents in polynomials. So this one is no. However, it is okay if you have, let's go back to red perhaps, it's okay if you have x over 3 plus 4, right? It's okay to have a fraction as long as the x is not being divided by, because this thing really just equals 1/3 x plus 4. So it's got a coefficient on the variable that is a real number, right? Do we all realize that 1/3 times x is the same as x over 3? Those two are the same, right? And then also 3x squared plus 4xy. It's okay to have more than one variable. It's a 4, believe it or not. It's okay to have more than one variable on a term. That's probably good enough. So this is yes. This one is yes. The first one is no because you had a negative exponent. And you can recognize a negative exponent because there's a variable in the denominator. All right. First of all, don't stress about what a polynomial is or is not. It'll be okay. I'm probably not going to test you on that even, but a good thing to know going into future years. All right. This is good terminology to know here. Polynomials that have a certain number of terms have a special name. A polynomial with one term is called a monomial. For instance, 3x squared would be a monomial, one term. You probably know that mono means one. Two terms, I'll bet you could guess that. Two terms is called a binomial. So that might be something like 4x squared plus 7. You know, like a bicycle, bi means two. Bicycle has two wheels. Binomial has two terms. And last up, three terms, I'm sure you can guess this by now, is called a trinomial. Tri, of course, means three, right? Like tricycle. An example of that might be like 2x squared plus 7x minus 42. And there you go. Those are good to know, I feel like. Monomial, binomial, trinomial. After three terms, there is no special name. After that, they're all just polynomials. And in fact, these are also polynomials. It's just if it has one term, it's a polynomial that has a special name called a monomial. All right. We have one more thing and we're done. See, another quick one. Multiplying polynomials together. I'll do the easy ones first, then I'll do a couple hard ones, and we will call it a day. So, if I am multiplying a monomial, which is one term, times any size polynomial, that might look like this. 2x times 5x squared plus 6x minus 2. All right, you already know how to do this, I'm hoping. And that is, we're just going to use the distributive property, right? We're going to multiply the 2x times each term in the trinomial. So 2x times 5x squared would give me 10x to the third, all right? 2x times 6x would give me 12x squared, and the 2x times the negative 2 would give me negative 4x. Pretty easy, right? We'll try one more. How about x squared times 5x minus 7? You might want to pause the video, see if you get the answer, and then turn it back on. Let's see if you got it. It would be, let's see, I would multiply the x squared times 5x. That would be 5x to the third. And the x squared times the negative 7 would be negative 7x squared, right? Reasonably easy, kind of stuff we've already done. But how about any size polynomials? So for this, you technically still use the distributive property. You simply multiply each term in the first polynomial times each term in the second polynomial. And then, maybe I should have put this up there then combine like terms. So let me do a couple of these and we'll be done. I'm not going to do a third example, so we can get rid of example 3 there. Here we go. Let's start with a binomial times a binomial. All right? Now, normally I would not write all this out, and you do not need to write all this out, but for demonstration purposes, I'm going to do it. I'm going to start with the x. I'm going to multiply the x times each term. So x times x, and then plus x times negative 3. And then I've got this positive 7, so plus 7 times x, and 7 times plus 7 times negative 3. All right, so I'm simply multiplying the x times each thing and the positive 7 times each thing. And my results are x times x gives me x squared. X times negative 3 gives me negative 3x. 7 times x gives me 7x. And 7 times negative 3 gives me negative 21. Make sure you pay attention to the signs, right? And when I go to combine my like terms, these guys in the middle are like terms. So I would get x squared plus 4x minus 21. And that is my final result. Let's try a more difficult one and we will be done. We are going to do a trinomial. We are going to do 2x squared plus 3x minus 7 times x squared minus 4x plus 5. All right, so we are going to start with, well, we're going to multiply each term in the first polynomial times each term in the second. So we're going to start with the 2x squared and do him. And watch how I write this out. That's, to me, the important thing here. Watch how we write it out. 2x squared times x squared would be 2x to the fourth. And then I would do 2x squared times negative 4x. That would be negative 8x to the third. And finally, 2x squared times positive 5. That would be positive 10x squared. I'm done with the 2x squared. I am now moving on to the 3x. And I'm going to do 3x times x squared. That would be positive 3x to the third. So I'm going to take that positive 3x to the third, and I'm going to line it up with my other x to the third term that I already have. Lining this up will make it easier to combine my like terms at the end. I've also got this 3x times negative 4x. That'd be negative 12x squared. So I line that one up. And finally, 3x times positive 5, that'd be positive 15x. And I'm done with that one, which brings me to the negative 7. So last, I need to do negative 7 times each thing. Negative 7 times x squared would be negative 7x squared. Let's group that with the x squared terms. Negative 7 times negative 4 is positive 28x. And finally, negative 7 times positive 5 is negative 35. I am now ready to combine all my like terms, and I've got them all grouped nicely together. So my final result here is 2x to the fourth. I've got a negative 8 and a positive 3. That would be a negative 5x to the third. Here I've got a positive 10 and a negative 12, which makes negative 2, and a negative 7, which makes negative 9. And then that would be positive 28, 38, 43x minus 35. And this is my result when I multiply those two trinomials together. You got it? Good luck. You can do it. See you tomorrow.